In this session, we deal with higher order functions, HOF, higher order functions. There are a couple of higher order functions. One is filter, one is map, one is sort, one is reduce, Flatmap, compactMap. These are the 6 higher order functions which are available in Swift. Even other languages also we have the same thing. The purpose of these higher order functions is to iterate through the collection and perform some action. Iterate through collection. Collection is we are having arrays, dictionary sets, right? On top of collection, these are performed. These are performed. It performs some action. Filter means to filter some items. To filter some items. Mapping we see to get something out of the filter, and sorting means sorting, assigning order, descending order. Reducing, what it does, it groups multiple values and makes single value. Kind of performing sum on entire array. And Flatmap, what it does, it flattens. compactMap removes the nails. Anyways, let me show you everything on a practical. Filter. Let me take an array. Array is of type strings. I'm having Naveen, Alex, Steve, Ramu, Abdul, Rena. Some names I have. I want to filter this array, and I want to get only names which are starting with A. Only names which are starting with A. How can we do? We can use for loop and do this operation. Like let new array equal to empty. Make this var for I a name in array. If a name has suffix A or a name has suffix small a. If a name is starting with A, suffix means, sorry, prefix. Suffix means at the end. Has prefix small a or capital A, then new array dot append new element. Let me, this is a string array. Append a name and print this. Print new array. Let me block this. Okay, simply we're having an array. I'm checking all names which are starting with A. Alex and Abdul are started with A. This can be done by using filter. Let me do new array dot remove r. I'm removing everything, and new array equal to array dot filter. What it is filter? If you see the types, filter. What is the filter? Is included. We have, and what it is having, which is giving you the string and which is returning you the boolean. This is a closure. This is a closure. If you clearly see, string and return is boolean, and the entire closure gives you the. Actually, there are two closures it seems here. Filter is a method. Filter is a method which is taking input argument as a closure. The input is string we need to pass, and return type is collection of strings it gives. What it returns an array containing in order the elements in sequence that satisfying the given predicate. Predicate means condition. Okay. Actually, this is a closure. This is trailing closure. What we can do trailing closure, just enter. What it is giving you, you see here, this is a closure which is giving you integer, which is giving you, which is giving you string, and you return something boolean. I'm writing that a name we are getting here. If a name dot has prefix a or a name dot has prefix small a. That's it. Now print new array and see what it has. Here is first new array, second new array, which is written with the same result. But comparatively, this takes much time. This takes less time actually. This takes more time. This takes less time. Filter. What is the purpose of filter? Filtering out some elements based on some condition. You can also put a return here, which asks for a return, right? Return something. Which asks for return boolean. Okay. Array dot filter. See here, it is a closure which is giving you input string, which you need to return boolean. Which you need to return boolean. Same thing, giving you a string, return something which you need to return boolean. The boolean I am writing here. The same thing can be done in another way as well. Some more shortest way. New array dot remove all, everything removed. New array equal to array dot filter. There is a closure, right? One argument we have. We can write this as $0 means first argument dot has prefix a. Print a new array. This is called shorthand notation of closure. The result is same, but single line of code. Inline closure. Inline closure also we can say inline closure. Say in the same line, the closure is completed. Here, this is a multi-line, right? Whenever you use dollar means the input argument which we get. First argument, $1 means second argument. Sometimes the closure might expect multiple arguments. If you want to refer them by using dollar notation, $0, $1, $2. Is this clear? Filter. Now we have map. Map is very, very important. Let's see, sort. This is sort. Map I need to recall. Yeah. Sort. How to sort? We're having let print sorted array. Sorted array. Let me put sorted first. Sort by. What it is? See here. Here it is again closer. Sort by. We are getting two input arguments, two strings we are getting, and we need to return boolean. We need to return boolean. Okay, this method is implemented by someone else. We are simply calling. Wherever you are calling, there we need to have our implementation, right? Wherever you are calling, there we need to have our implementation. This is the implementation. Here also same thing. We are implementing it. There is a method already existing, sorted by, or giving you two strings and returning boolean. Short way we can write, right? $0 means first string. Less than I'm simply giving $1. This is the condition which returns if it is successful, it returns true, false. Let a sorted array. This is shorthand way of writing. Okay. Normal way also can write. Anyways, sorted array. Run it. Sorted, right? Sorted in reverse order. We can write less than, and see assigning order. A Abdul, Alex, Naveen, Ramu, Rena, Steve. This is how we sorted. Now let me try mapped array. Let's see even I don't know. Mapped array equal to array dot map what it is are expecting. Yeah, mapping. Mapping basically the main purpose of map function is whenever you are having complex data types. Complex data means arrays. Within the arrays you have dictionaries. Dictionaries inside we are having dictionaries, sub dictionaries, etc. If you want to get only internal elements sometimes. Only internal elements like hierarchy. Let's say there is a top hierarchy array. Within the array, I am having dictionary. Within the dictionary, I am having array. Within the array, I am having one more array. If you're having such kind of hierarchy, if you want to get the bottom or middle hierarchy object, then the map will be used. The map performs operations on anything, everything. Here, what it is expecting, what it is giving, it is giving you string and returning you the same type. Returning you the same type, whatever we get here. String, we're getting a string. We can say a name. What I do is on the all names, I'm going to perform some operation that is called the uppercase. I'm writing something. I want to convert everything into the uppercase. Mapped array. Map iterates to the collection of elements, all the elements of the collection. The same operation you can perform on the object. Let me give you one real-time example. Let us write some complex here. Let us try. Let me take a class. School. Let us take simple example. Class. Student. Right, name. History. Let A is equal to integer. Let students equal to students. Let me create a couple of students. Student. Ravi, age is 20. Ram, age is 21. Somu, age is 20. Pramod, age is 19. Rakhi, age is 20. Ammu, age is 20. That's it. Age is 21. There are a couple of students in a school. Let me create a student. I want to get all the names of the students here. All names of the student. Let me create a school. My school equal to school. I want to get all the names, only names, not the complete student information. I want to get only names or only age. How to get that? Let me try even dot students dot map. Map what it gives? One element. Each element is student here. Student. What I wanted? A student dot only names I want. All names. Very useful actually. Map is very useful. All names I'm printing. Right, if you can get. We got Ravi, Ramu, Somu, Pramod, Taki, Amul. Okay. Within the school within the dictionary. If you want to get some particular element also, you can get some particular only age. If you want only ages, you can get. Very, very useful actually. Maps filter also is also very, very useful. Okay, whatever you want, that will be written. If you want to perform, let's say for all the years, I want to add one extra, you can do that as well. 21, 22, 21, 20, 21, 20. We have 19 as well, right? 19 is not there. If you want to perform some specific operation on all the objects, then also that also can be performed by using map. Now, plot map. Let me take a 2D array. 2D array. 2D array means this is array 1, 2, 3, 4, 5. This is one array. This is one dimensional array, we can say. If you have multiple arrays, 6, 7, 8, 9, 10. You have multiple arrays in a single array. This is 2D array. This is one dimensional. This is another dimensional. 2-dimensional array. Now I want to perform plot map. That 1D array equal to 2D array. Actually, this is not accepted. Starting with the number is not accepted. Underscore 2D array dot. This is plot map. What it is giving you? It is giving you array of integers. Just for that sequence, let me put shorthand way 0. Even I don't know. Print underscore 1D array. What happens is, if you see, the 2D array became 1D array, one step back. If it is 3D array, it becomes a 2D array. Let me, this is 1D array. Let me make one more array here. This is 1D array. This is 2D array. Okay, here I am having 11, 12, some numbers 575. Run it. What it does? One step back actually. One step back. This is one object. This is another object. What it does? This is entirely one object. Okay. Here one dimensional. This is 3D actually. This is actually 3D. What it does? If you see here, 1, 2, 3, 4, 5, 6 is opened and kept outside, and this has an argument. This is 2D, right? Became 1D again. Basically, one step back. If it is 3D, it converts 1D. 2D. If it is 2D, it converts 1D. Okay, this is 2D array. Again, within this, there is 2D array. The entire thing is 2D array. Now it became 1D array, single dimensional array. This entire thing is 2D array. This became 1D array. Is it? Yeah. The extra space is gone here. Extra square braces is gone here. At 6, there are 2 square braces. It opens and put. This is plot map. There is something called compact map. Plot map, what it does? Flattens the dimensional arrays. If it is 3D, it becomes 2D. If it is 2D, it becomes 1D. Anyways, compact map. Compact map removes nil objects. Let us try. Don't know what is this. Basically, you just need to understand what is the close, what is the input, what is the output. If you know that, everything is simple only. Later, where a is of an integer, I'm taking nil. Where b is of an integer equal to nil. Where c is of an integer equal to 10. Let numbers array equal to numbers array is after integer question mark equal to a comma b comma c comma 10 comma 30 45 comma 36. Basically integers. Out of integers, 4 are actually contains the values C can have, but 2 are not containing a values. A and B are nils actually. Now let me even we have some issue with this. Let me try what we did that time. Compact map numbers or compact map. What it is giving? It is giving you integer optional and returns something. Let me put simply 0. That a equal to something, print a. What it does? It removes the nils, right? It removed the nils. Here, let me print this new array, number array. Number array contains nil, nil, 10, 10, 45, 36. Once you perform compact map, what it did, it removed the nil, removes nil objects. In interviews, they will ask you what is the difference between plot map and compact map. Very, very important. Higher order functions, 100% question again. Higher order functions. Okay. Plot map flattens the multi-dimensional array into a next level dimensional array. Whereas compact map removes the nil objects from the collection. Filter is to filter in the objects. Map is to perform any specific operation on entire objects. Sort means for sorting. There is one thing called reduce. Reduce is a little tricky, but we never use the reduce. Reduce, what it does, let's say, even I don't know how it is. Let me take my numbers array equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total is actually 55. Let result equal to my numbers array dot reduce the initial result, next partial result, the entire result, initial result where sum equal to 0. I'm just putting sum here. Here we're getting partial result into a number. Sum plus I, even I don't know what it is. Anyways, see, sum plus number. What is this partial result? Let's print and see result what it is. It has given you 10. Partial result 55. Yeah. Reduce, what it does, if you want to club all the values with some starting initial value, you can also add. This is some 150, 100, this 55 is this. Reduce, we never use even, there is no proper use case to use the reduce as well. You can check on Google, like when exactly to use the reduce. These are the higher order functions and the closures. Any doubts here?